Our last topic was about percent composition, but let's take a recap or review on this one. So percent composition, one can find the percentage of the mass of a compound that comes from each of the elements in the compound by using this equation. The percent element is number of atoms times the atomic mass or the molecular weight or formula weight over the formula weight of the compound times 100. So say for example, you are looking for the percentage composition of carbon and ethane. Ethane is C2H6. So if you want to get the percentage composition of ethane, uh, you multiply the percent, uh, the mass of the C or carbon times the number of atoms present in the C2H6, which is 2. And then i-divide mo na siya sa formula weight sa ethane, which is 30.070. So the atomic weight for carbon is 12.011. So the percent composition of C in ethane is 79.887. Calculate the percentage of carbon, hydrogen, and oxygen by mass in C12H22 or O11 sugar. So sucrose. I think this is sucrose. So percent C is you just multiply 12, which is the number of C carbon in C12H22O11 times the atomic mass of carbon, which is 12 or 12.01 divided by 342. 342 is the sum of all the masses, product of masses of each element. So the carbon is 12 times 12.01, H is 1.01 times 22, then O11 is 11 times 16. So that's 342. So the percent composition of C is equal to 42.1%. For percent H is the H alone, you need to get H22. So 22 times 1.01 divided by 342. So the percent composition of hydrogen is 6.4%. And then the percent O is, pwede rin mo siya kung makita mo ang C of H, which is the third element is O. You need, pwede rin mo i-deduct ang 100 minus 42.1 minus 6.4 and get the 51.5 instead of getting the 16 times 11 divided by 342. So that's applicable for the remaining element, which is usually O. Next one, we have Avogadro's number and moles. So Avogadro's number, in a lab, we cannot work with individual molecules. They are too small. That is why na-representation for the small atoms or the micro size atoms. So naano siya ang purpose ni Avogadro's number. That is 6.02 times 10 raised to 23 atoms or molecules in an amount that brings us to lab size. So that represents the micro size of specific element. So talking about carbon, so if the composition of the carbon is too small, so you need to use dimensional analysis and then to cancel the small size atom or unit by 6.022 times 10 raised to 23. Pwede siya atoms, pwede siya molecules. So if the question is there are 23 molecules of carbon, so makancel ang katong 23 molecules of carbon using the 6.022 times 10 raised to 23 molecules of carbon is equal to 1 mole of carbon. Muna siya ang representation. If ang i-ask for that specific is how many moles of carbon is present in 23 molecules of carbon. So mo tayo gamiton na dahil Avogadro's number. So 1 mole of 12 carbon or carbon 12 has a mass of 12 grams. That's it. That's Avogadro's number. So, kani siya ang iyahang representation. So, it can be used as mole, atom, or molecules, atoms, and then particles. So, 6.022 times 10 raised to 23 particles per mole, or 1 mole is equal to 6.022 times 10 raised to 23 particles. Make sure na ang iyahang counterpart ani, like kung ang Avogadro's number is nasa numerator, dapat ang iyahang or makancel ang particles or the Avogadro's number, you need to pair it with a denominator na value in particles. Say for example, or molecules. So by definition, molar mass is the mass of 1 mole of a substance. Example is grams per mole. So that's the value of nasa periodic table that one. So that's the molar mass of carbon. So that is 12 grams of carbon per mole of carbon. So man siya ang molar mass. So the molar mass of an element is the mass number for the element that we find on the periodic table. The formula weight in EMU or atomic mass unit will be the same number as the molar mass. So para di mo maglibog, we are using the formula weight is in EMU and the molar mass is in grams per mole, which is mo na siyang makitaan sa periodic table. So 1 mole of carbon contains 6.0222 times 10 raised to 23 carbon atoms. The same way with 1 mole of water, which is also equal to 6.02 times 10 raised to 23 molecules of water. And then same for 1 mole of NaCl. For 1 mole of NaCl is there are 6.2 times 10 raised to 23 sodium ions, and then 6.02 times 10 raised to negative at times 10 raised to 23 chlorine ions. So that's for the particles representation of Avogadro's number. So examples of mole. So 1 mole of magnesium is equal to 6.02 times 10 raised to 23 magnesium atoms. If paano yung molar mass kung saan nadara sa periodic table, that's the molar mass of magnesium, and also for Au or the gold. So if you will get the atoms, number of atoms, you need to use the Avogadro's number. So 1 mole of NH3 is equal to Avogadro's number NH3 molecules. So inana ka kuan powerful ang Avogadro's number na you can use it anytime. So example, how many atoms are there in 0.551 grams of potassium? So 0.551 grams of potassium. Ito sa potassium. So 1 mole molar mass. Molar mass of potassium is 39.10 grams of K per mole of K. How many atoms man? So imong gamiton na is that imong starting point is the 0.551 grams of potassium. So para makancel ang grams diri sa taas numerator, you need to have a gram per K diri sa denominator. So we'll use this molar mass na relationship. So for every mole of potassium, there are 39.10 grams of potassium per mole of potassium. So this is coming from this one, the molar mass. Now, makancel na imong grams of potassium. Now, na kay mole. Per mole of your K is you have how many atoms? That's the purpose of Avogadro's number, 6.022 times 10 raised to 23 atoms. To perform necessary operation, which is 0.551 multiplied to 1 times 6.022 times 10 raised to 23 divided by the product of the denominators is 39.10. So the answer will be same like this, 8.49 times 10 raised to 23 atoms, 21 atoms, 8.49. 8.49 times 10 raised to 21 atoms of K. So cancel ang mole K, sa nabili na lang na unit is the atoms, the numerator. So using moles is moles provide a bridge from the molecular scale to the real world scale. So from grams, you need to naamang kay relationship dito sa molar mass niya, which is the grams per mole. Makuha nimo ang moles. From the moles, use the Avogadro's number to get the formula units, which is the molecules, particles, or atoms. So that's the relationship of na gikan ka sa grams padulong sa kung sa imong desired na unit. Calculate the number of moles of glucose, C6H12O6 in 5.380 grams of your glucose. How to solve this one? So you need to get first the formula weight of your glucose, which is, how to get that one? That is 6 times 12.01 plus 12 times 1.01 plus 6 times 16. So that is around, kailan na? $180.07. Ito ba? 180.07 grams of your glucose per mole of your glucose. So that's the formula weight or molecular weight. Formula weight is the katong the EMU. So kanina we'll use the molecular weight of the glucose, which is, ang unit niya is grams per mole. Now, so sakto 180 no ang gamit. So kuha na to ang number of moles of glucose gikan sa imong initial sample, which is 5.380 grams of your glucose. Glucose ng GLU, ako na lang siyang ano, instead na writing it sa C6H12O6. So again, to cancel this one, the grams glucose, you need to use the grams glucose also sa imong denominator para makancel imong grams glucose. So ang relationship na gamitin nato is the molecular weight of your glucose, which is 180.07 grams of glucose per mole of glucose. Sir, sa iyong formula weight or molecular weight niya, sir, kaya naman sa taas ang 180.07. So ang 180.07 attached na dapat sa grams. Di na siya dapat ma-change diri kay moles. As is na siya na mole is 1 mole. So mo na siya ang purpose nganong inana ang nitabo, nganong wala na retain si 180.07 diri kay numerator. So mo attach siya dapat kay grams. Kaya this is timbang of your mass of your glucose over isa ka buo na glucose or mole of your glucose. So this one, makuha na nato ang number of moles. So that is 5.380 times 1 divided by 180.07. So that is equal to 0.0289. O baka makakita. 2989. 2989 moles of your C6H12O6. How many moles of sodium bicarbonate are in 500 grams of sodium bicarbonate? So same process, itong buhaton. So we'll get the molecular weight of your sodium bicarbonate. So that is molecular or formula weight or molecular weight. Formula weight or molecular weight, para di lang tama ko, it's the same thing naman Japon, ang ilalang unit lang. Pero for this one, since we are looking for this specific moles, so we need to get the molecular weight or the grams per mole. So that is equal to 23 ang sodium times number of atoms present na sodium dahil sa sodium bicarbonate, because 1 plus hydrogen is 1.01 times 1 plus the carbon is 12.01 times 1 plus oxygen is you have 3 times 16. So that's the equation for the molecular weight of your sodium bicarbonate. Please check if sakto ba ang sodium, that's 23 or 22.99. Tanawin per the table.
Sakto, sir.
Okay. Look for sa Google ninyo, molecular weight of sodium bicarbonate. Mugawas dapat ang 84.02 grams per mole. Molecular weight of sodium bicarbonate. That is equal to 84.007. So we'll follow our 84.02 since we are using 23 here. So 84.02 grams per mole of sodium bicarbonate. So the problem has a mass of 508 grams of your sample, which is the sodium bicarbonate. Sir, nga nung bicar man na siya, sir, because of the H. Kung NaCO3 na siya, carbonate na siya. Mali siyang patong last time na sodium carbonate. So, kanayihang distinction or timailhan na sodium bicarbonate na siya. So, grams of sodium bicarbonate, use the molecular weight of your compound. So, 84.02 grams of your NaHCO3 or sodium bicarbonate per mole of your sodium bicarbonate or SB na lang. Okay. Tapos what? So, makancel yung grams and grams, the denominator and the numerator. Sir, makancel bang numerator to numerator? No. Mamultiply man nimo siya. So, mas-square siya. So, dapat ang imong partner is baba numerator, ay taas numerator, dapat baba na yun ang imong i-partner. Same units para makancel. So, mabili na lang na units is the mole of your sodium bicarbonate. So, perform necessary operation. So, that is 508 grams divided by 84.02. So, that is around 6.046179 mole of your sodium bicarbonate or NaHCO3, sir. The kay lagi decimal places is because wala may butang dira kung pila ang significant figures necessary for the operation. So, if you'll use lang, kanang instinct lang na pili gamito na significant figure, we will use the 3, which is marang po given. Sir, i-use bang molecular weight? No, dili na gamiton. Ang kanilang present there is a problem, mo gamiton ng significant figures. For this one, that is 508, you have 3 significant figures, so pwede na itong round off to 6.05 atong answer. Mole of your SB or sodium bicarbonate. Finding empirical formulas. Sir, sakto na ba rin? Wala pa rin ka nag-end atong empirical formula. Yes, the most used method on getting the empirical formula of a certain compound is that divide the ratio sa ilahang number of atoms, specific atoms, dito sa ilahang tawag ani common nila na factor. So, you say for example, glucose, glucose, that is C6H12O6. So, divisible pa ang each subscript, no? Ang 6, 12, og 6. So, i-divide mo na siya sa 6. So, may tabuan na. May mo siyang CH12 or C1H2O1 or CH2O. So, that's the empirical formula of the specific compound. Now, in this topic, inana ang may tabo na looking for empirical formula, no? But you need to get the ratio and multiply it to the equation. So, ato na i-check ko niya. So, calculating empirical formula, so the given, you have mass of percentage of elements, then you assume, so that's the time na mag-assume na kag 100 grams of sample. Kung saan nag-sample, sir? Katong specific na kan, for example, you're looking for glucose, and you don't know the molecular compound or molecular weight of that specific ng glucose. So, nag-assume ka na na component ni C, H, o O. Ihatag na siya. So, assume ni kag 100 grams of your sample of glucose. So, and then, makuha ni mo ang grams of each element. So, say for example, the percent composition of carbon is 22%. The H is 2% and O is 80%. So, kung itotal mo na siya dapat, 100 na siya. So, meaning to say, katong 22%, that is 22 grams. Di mo assumption per each equivalent sa component, ay each component nimo. So, sa C, H, o O. So, that's for the first part. Then, after makuha nimo ang grams of each element, then use molar mass. So, say for example, ang 22 grams yung nakuha. 22 grams or 22% of your carbon is equal to 22 grams of your carbon element. And then use the molar mass of your carbon to get the moles of your element. So, muna siya ang 22 divided by 12.01. Sir, nga 12.01 man, sir? It's because 1 carbon naman imong i-multiply nimo kay carbon component naman siya. So, 22.01 divided by 12.01. That's the atoms of, a mole of your carbon for that specific unknown compound. So, makuha na nimo ang mole component sa isa ka element, each element. Tinusahan pagkuha ang mole ratio. So, get the either imo siyang i-multiply nimo sa pinaka-least. So, say for example, ang moles is sa C is 1.01, ang sa H is 0.93, ang sa O dayon is 1.25. So, i-multiply to nimo ang 0.97 sa specific number para ma-whole number siya. So, pila may multiply. So, multiply nimo siya o i-times 2 nimo siya. Say for example, so, may mo na siyang whole number. So, kato na dayon mo na itong empirical formula for that specific compound. Ang katong pag-multiply, say for example, 0.97 times 2, so that is 1.90 or 1.80 plus kapin. So, i-round off to nimo to 2. So, that's the mole of your H sa compound. So, inana mo i-conduct sa same sa component sa A, sa C, and then sa O. So, ato na i-try din, no? How to calculate this one. So, maklaro na ba? So, the compound para, amino, meaning kung may pagpara, kung madungog ka sa organic sa para is kuan sila kanang they have murag na sila distant, di sila friends kay na sila kanang ano, that's the opposite na kuan. So this is the first attachment of amino, and this is the side sa another amino compound ay amino na tawag amino acid diri na part. So opposite sila, no. So benzoic acid man siya, so na siya benzene ring. So ang yang structure din is ang benzene is naman siya 6 na sides, no, ang benzene ring. So or katong lantawa ang kuan, lantawa ang yatos na itsura. So that's benzene ring. So ang para pasabot ana is the opposite na kuan. So na sila sa opposite end. Na sila ay kuan itawag ani. So na sila diri. Dari yung specific amino, and then this is another amino. So that's the para. So the compound para-aminobenzoic acid, you may have seen it listed as PABA on your bottle of Sanskrit, is composed of carbon, that is around 61.31%, hydrogen 5.14%, nitrogen that is 10.21%, and oxygen that is 23.33%. So find the empirical formula of your PABA. PABA. So first one is assume kaog 100 grams, diba? That was the first step. So meaning to say, your carbon is 61.31 grams of carbon. Your hydrogen is 5.14 grams of your hydrogen. Your nitrogen is 10.21 grams of your nitrogen. And your oxygen is 23.33 grams of your oxygen. I-add ganina siya. 100 ba? So that is around 99.99%. So ang discrepancy maybe is diri na part, and then diri na part sa oxygen. So kaya siya. So next step would be to transform each of the component to its mole niya na itsura. So saan man i-multiply na to siya sa molar mass. So this one i-multiply na to siya sa 12.01 grams of your carbon per mole of your carbon. So makuha na nimo ang mole sa imong carbon. So this is the numerator, 6 grams of carbon, denominator grams of carbon. So you have how many moles of your carbon? 61.31 divided by 12.01. You have 5.10. 5.1049 moles of your carbon. So atong buhaton na siya, same diri kay grams of your hydrogen. So molar mass of your hydrogen is 1.01 grams of hydrogen per mole of your hydrogen. So makuha nimo ang mole of your hydrogen, which is equal to 5.14 divided by 1.01. So that is around 5.0891109. Sir, ano dagan kay decimal? So again, you need to get the most number of decimal sa imuhang calculation to be more accurate sa imuhang result later on sa katong final nimo na answer. So for this one, akong gikuha is around 4 to 5 na decimal places. So for nitrogen is i-divide na nato siya og 14. 1/14. So ang unit niya is mole per gram or gram per mole. So 10.21 divided by 14, that is around 0.029 28 7292857. So you can calculate also diya sa inyong mga balay, inyong mga table karon kung sakto bang calculation, kung nabay mali or kuan. For oxygen is divide na to, multiply na to siya sa 1/16. It's because there are 16 grams of oxygen per mole of your oxygen. So 23.33 divided by 16, so that is around 1.458125 mole of your oxygen. Now, after this one, nakuha naman yung mole, use the pinaka-least sa upat ka values. So this one is 0.729857, 92857. So each element, i-divide mo siya ani na number. So si carbon, so ang ratio na rin niya is 5. For carbon is 5.1049 divided by 0.72 9857. So that is around 92857. So that is around 6.99 or equal to 7. For your H is, ang H component mo is 5.089109 divided by same denominator, 0.72, 92857. So you have a result of 6.97. 15208 9109 divided by 0.72 92857. 6.97 or equal to 7 also. Sir, pwede siya ma-round off, sir? Yes, pwede siya, 9.90 naman iyahang waki. But if 1 pa siya, di pa kayo siya mga 6.40 plus pa siya or 6.50, na po yung other button no? Pero kani is ato ang i-round off lang sa siya. For nitrogen is you have ma-round off naman ang number. So that is 0.72 divided by 0.72. So equal to 1. So i-divide mo iyang self. Ang i-divide mo kanina number sa iyang self, so that is around 1. And then your oxygen is 1.425 divided by 0.72. So pila man, around 2 na siya. 42, like 1.458125 divided by 0.72 92857. So that is around 1.99 or equal to 2. So meaning to say, this will be the final empirical subscripts or atoms of your each component. So meaning to say, the empirical formula of PABA or para-aminobenzoic acid is C7H7N1O2 or C7H7N2. So, pwede lang i-exclude natin yung 1. Kaya as is naman na siya as 1 kung wala siya ano. So, this will be the formula of your para-aminobenzoic acid. Okay, next topic will be about combustion analysis. So, balik ka sa combustion analysis. It's the reaction between a hydrocarbon to your oxygen compound or oxygen molecule. So, compounds containing C, H, and O are routinely analyzed through combustion in a chamber like the one shown in this figure. So na kay O2, you have a sample, then you have exposed it to O2, i-combust mo siya using O2, and then you have the H2O absorber, or siya makuha sa water na component, and then you have the CO2 absorber. So that's the two product of your combustion analysis, the water and your carbon dioxide. So the mass gained by each absorber corresponds to the mass of CO2 or the water produced. So that's combustion analysis. So quantitative relationship, the coefficients in the balance equation show the number of molecules of the reactants and the products. So relative number of moles of reactants and product which can be converted to mass. Meaning to say, if you are given the number of your, say for example, H2 and then oxygen imong react, and then you have the 2 molecules of water na product. So if ang question is the number of product lang ang gihatag, so you have 25 grams of your water produced in the reaction of your hydrogen and oxygen, how much hydrogen will be needed in the reaction para ma-feasible ang reaction? Meaning to say, you need the balance equation or the balance reaction para makuha nimong relationship atong moles. So say for example, dati, ang balance reaction niya is you have, for every 2 moles of your hydrogen gas, you need a 1 mole of your oxygen gas para makakreate kag 2 molecules of your water. Meaning to say, for every 2 moles, so say, for example, you have 5 atoms of water na gigamit. So, for grams ng yung grams, i-convert mo siya sa mole. Saan man, i-multiply mo siya sa molar mass or molecular weight sa imong water, which is 18 point something, 18.01. So, that's for water. So, grams of your water, grams per mole, so nakay mole of your water. So, imo ni gamiton din kay for every 2 mole of your water, you have 2 moles of hydrogen gas needed. So, nanakay makuha na atoms ay moles of your hydrogen gas. So, that's the relationship or purpose of needing the balance equation or balance reaction for a specific balance equation for a specific reaction. Ano siya? Okay. Mulay kuan. Okay, stoichiometric calculation. Starting with mass of substance A, you can use the ratio of the coefficients of A and B to calculate the mass of substance B form. So, matang din yung ganina, no? You need the balance equation first before ka makaproceed. You don't assume na your reactant A and then reactant B is you need 1 mole each para maka-form ka og 1 mole of your reactant product. Dili siya. So, dapat sa kanang sa law of conservation of mass. So, dapat balance ang number kung sa imong gigamit number of atoms diri sa imong reactant. It need to be kanang equate or it need an equal number of atoms dito sa imong product. So that's the stoichiometric calculation part. So say for example, the combustion of your glucose. Once you combust the glucose, magka-result of CO2 and water. So i-balance na nato siya. So check nato, no, you have 6 carbon here, then you have 6 carbon sa product. Then for your hydrogen is you have 6 times 2, that is 12. 6 times 2. Now your oxygen is you have 6 here times 2, so that is 12, plus 6 times 1 is 6, so 6 plus 12 is 18. So you need 18 sa imong reactant para mabalance ang reaction sa combustion sa glucose. So this one is you have 12, 6 times 0, 2, and plus 6, so 18. So balance na siya. Meaning to say, you need 1 molecule of glucose and then combust it, react it with your 6 molecules of your oxygen gas para maka-form ka og 6 molecules of your carbon dioxide and 6 molecules of your water. So, mo na siya ang purpose or the purpose of the coefficients in the balance reaction of each component or each reactant and the product. Ano siya? Dissolve. Solid lithium hydroxide is used in space vehicles to remove the carbon dioxide gas exhaled or released by the astronauts. So the hydroxide reacts with the carbon dioxide to form solid lithium carbonate and liquid water. How many grams of carbon dioxide can be absorbed by 1 gram of lithium hydroxide? So let's check if the reaction is already balanced. So you have the reaction here. The lithium hydroxide reacts with the carbon dioxide to release the water, and then the solid lithium carbonate. So, pero nakabalance mo siguro niya. So you have 2 lithiums here and you have 2 lithiums in the product side. So you have carbon is you have 1 here. Water, H is you have 2. You have 1 times 2, so you have 2 H. And then for your oxygen, you have 2 here, and then you have 2 here. Then sa pika side is you have 3 plus 1. So you have a balanced oxygen also for each side. So we need to say this will be a balanced reaction for balanced equation for the reaction of lithium hydroxide and then carbon dioxide. So the problem is that how many grams of carbon dioxide is needed, no, or can be absorbed by 1 gram of lithium hydroxide. Meaning to say, pila daw ang i-react nimo sa 1 gram of lithium hydroxide para maka-release ka or maka-produce ka of lithium carbonate and then the water. So you just need this 1 gram of your lithium. Pila ang molecular weight sa lithium? Nasa group 1. Pa-check down. Molar mass sa lithium. 6.94 grams of your lithium per mole of your lithium. So, meaning to say, makancel na yung grams of lithium. So, na kayo nabili na moles of your lithium. Now, ang ipangutan naman is the carbon dioxide na side. So, maulit ang relationship din sa coefficients. So, ikan ka sa lithium, pila ang ganito na lithium, molecules of lithium or moles of lithium para mabalance imong CO2. So, for every 2 moles of your lithium, you need 1 mole of CO2 only. So, makancel mo ang mole lithium, no? Mabilin ka sa mole CO2, but the problem is how many grams man. So, paunin mo ang graphs component ani. So, for every mole of your CO2, pila man. So, that is 16, 44 man natin yung CO2. 16 plus 16 plus 12.01. 44.01 grams of your CO2. That's the molecular weight of your CO2. So makancel ang mole CO2 and then mole CO2 sa denominator. So mabiling ka, you're left with the unit grams CO2, which is mo na itong ginapangita. So perform necessary operation. So 1 gram of 1 times 1 times 1 times 44, so that is 44, divided by the denominator, which is 6.94 times 2, that is 13.88. So you have 3.17 grams of your CO2 ang needed to react with your 1 gram of lithium para maka-produce ka og kana siya na product. Question. So this is not a combustion reaction. No? So this is the example for calculating the amounts of reactants and products using the balance coefficients of each component. The limiting reactant is the reactant present in the smallest stoichiometric amount. You have the limiting reactant, you have the excess reactant. Limiting reactant is katuloy mong first, siya ang first mahurot sa reaction. So, siya ang limiting. So, siya ang basihan or baseline nato kung pila kabuk ang gamiton. So, in the example below, the O2 would be the excess reagent or the excess reactant. It's because na totally consumed ang kaning H2, no? So, naakay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, si 10 ka H2 molecule, pag-abot din sa pikas na side is na-distribute siya sa mga oxygen. So, si oxygen din dire, si O2 component, you have 2, 4, 6, 7. You have 7 components of your O2 molecules. Now, pag-abot din dire sa pikas is you have 2 oxygen molecules. Meaning to say, nakay duha ka oxygen component na excess. Meaning to say, ang limiting reactant ani na reaction is the H2. Kaya siya ang first na kurot sa reaction. Siya ang wala na binlan. So that's the comparison of a limiting reactant and an excess reagent or excess reactant. Chapter 3. So this is the reaction. The reaction H2 gas plus oxygen gas yields water is used to produce electricity in a hydrogen fuel cell. Suppose a fuel cell contains 150 grams of your H2 or hydrogen gas and 1,500 grams of your O2, each measured to two significant figures. How many grams of water can be formed? Assuming na for every mole of your 2 moles of your H2, para mabalance ang imong reaction, you need 1 mole of your oxygen and then 2 moles of your water. So, saan na siya pag-calculate? So, same result itong ibuhat kanina. From this one, how many grams of your water? So, si water imong tanaw na to kung kinsay limiting ang aning duha. First, kung si H2 ba or si O2. Kung kinsay limiting, mo ito gamiton for calculation. Kaya siya may first mahurot. Okay, you have 150 grams of your H2. So, H2 is 1.01 times 2. You have 2.02 grams of H2 per mole of your H2. Then you have 150 divided by 2.02. So, you have 74 moles of your 24.26 moles of your H2 grams. For the other side, that is 15 grams of your O2. That is 32 grams of your O2 per mole of your O2. So, yung 32, it's because O2 itong gamit nila siya elemental. So, that is 16 times 2, nang siyang 32 siya. So, 15 divided by 32. So, you have 46.875 moles. So, kung ato pa ni siyang iikuan, ipadulong sa water. So, you have mole of your H2. Ang iyang comparison is per mole of H2, you have 2 moles of H2 para makaproceed ka to H2 per mole of your 2 moles of your H2O. So, meaning to say, using your reactant mo na H2, you will have 74.26 times 2 divided by 2, that is around 74.26 na dapon. So, mo na siya ang result nimo for mole of your mole H2O. While for your O2, is ang relationship is that 1 mole O2 will be used while H2O is 2. So, times 2 siya ng 46.875 times 2. So, that is around 93. 93.75. 93.75 moles of your H2O. So, meaning to say, sa may kuha ani limiting reactant ani. The limiting reactant would be your H2. Since na siya lower na value no sa 94.26 compared to 93.75. So the number of how many grams of water can be formed will be coming from this one. So imo ni siyang i-grams ni mo ni siya ang water na ma-form diri na reaction. It's because kaniman siyang first mahurot ang gikan sa H2. So siya tong gamiton na value. So ang remaining katong excess ni ani, kaning excess ani 93.75 mole of your water is mo ni siya excess value coming from your O2. So meaning to say 74.26 mole 1 mole times 18.02. So you have 1,338.17 grams of your water ang ma-form sa reaction. Gets? Theoretical final final topic will be theoretical yield. Theoretical yield is the maximum amount of product that can be made. In other words, it's the amount of product possible as calculated through this stoichiometric problem. Meaning to say, katong gisolve ganina, katong water, the grams of water, matong theoretical yield. It is not the same with your actual yield. Ang actual yield is using a systematic process or itong process gid sa kanang company or kung sa ilang pag-produce sa water, mo to siya ang actual yield. So, meaning to say, katong result kanina ng 1,338 diri na grams of your grams of your H2O, this will be the actual theoretical yield. Actual yield for this one could be, pwede siya og kuan 1,337.95 or 1,339 ay 38.56. So, ganyan ang mga values possible. It's because na ay tendency na dili siya accurate ang atong theoretical values atong kuan. It's because na losses along the way sa actual process. So, kani siya is given na usually ang actual yield, no? So, this is different from the actual, which is the amount of one actually produces and measures. So, gaka-measure ni siya. Ano siya ito gina-measure sa process, while the theoretical yield is just from the theory or the concept or principle na itong gigamitan. Kuha na ito siya, gamitan na ito siya theory or principle using the stoichiometric na relationship. So, ang percent yield, on the other hand, is the actual yield divided by the theoretical yield. So, kung sa tigikuan, the actual na gigawas over sa imong na-solve na times 100, that's the percent yield. So, say for example, this one, even na to ang actual yield is around 1337.95. I-divide mo na siya dira sa baba. 1337.95 divided by your theoretical yield, which is 1338.16. That is the value na imong na-solve or na-calculate using your relationships, stoichiometric relationships. So your actual yield is 99.98. That is your percent yield. Meaning to say, from this given percent, 0.02 ra imong loss. So meaning, na-convert nimo mostly or majority sa imong reactants, which is H2 and then O2. And you have just kanang nag-loss lang ka og around 0.02 during the process. Na padulong, sorry, loss na siya, nasa waste na siya padulong. So meaning, your process is considered as accurate process. Kaya na-convert nimo ang imong reactant to product. So that's the interpretation for percent yield. So last example, adipic acid or H2C6H8O4 used to produce nylon is made commercially by reaction between cyclohexane or C6H12 and O2. Now, we have the reaction, balance reaction, assume balance reaction below. And then the question is, assume that you carry out this reaction with 25 grams of your cyclohexane and the cyclohexane is the limiting reactant. What is the theoretical yield of the adipic acid? Dre is anak kay limiting reactant. Iya pang giingon ang limiting reactant daw is the cyclohexane. So kani ang cyclohexane daw ang limiting reactant, this one. So meaning siya atong gamiton na basis. So you have the 25 grams of your cyclohexane here. Dire-diretso na tanong, pero kung wala siya giingon, kung sa limiting reactant, ipasolve ka sa limiting reactant, the process would be use the initial na mga grams or masses of your reactants, and then i-ano nimo sila, imo nimo silang moles of your product, and then compare kinsa mas lower. Kung kinsa mas lower, siya ang limiting reactant sa iyang moles of your product. So this one is the ingon na limiting reactant. This is cyclohexane. We will compute for the theoretical yield. So 25 grams of your cyclohexane is C6H12. Compute for the theoretical yield of adipic acid, C6H12. So the molecular weight of your cyclohexane is 12.01 plus times 6 plus 12 times 1.01 plus 12.01. That is 84.07 grams of your cyclohexane per mole of your C6H12. Now, the relationship for this balance reaction is for every 2 moles of your cyclohexane, ang result will be 2 molecules of your adipic acid. Meaning to say, ang i-multiply nimo dire is 2:2. Meaning 2 moles of your cyclohexane is needed to react para makaproduce ka og 2 molecules of or 2 moles of your adipic acid or AA. Ito ikaw na lang practice taas. Meaning to say, yung cancel na kung 2 divided 2 is 1. So, more lang pag 25 divided by 84.07 or equal to 2.297 mole of your adipic acid. Now, adipic acid is kung ano yung molecular weight mo para makuha mo ang grams or the theoretical yield. So, adipic acid is 1.01 times 2, so 2.02. I-compute ang adipic acid times 10, 10.1, 10.1, 16 times 4, that is 64, 146.16. 146.16 grams of your adipic acid. I joke. Per mole of your adipic acid is you have 146.16 grams. Meaning to say, cancel mong mole, ang mabili na lang is your grams of your adipic acid or the theoretical yield. I-multiply mo na siya sa imuhang moles. So you have a theoretical yield of 43.4T 90 and 952. I-check daw kung natay wrong something. Adipic acid is 16 times 4, 64 times 8, 10, 10.1 plus 10.1 plus 64, 146.16 times 0.297. Okay. 43.40, meaning to say this will be our theoretical yield. Theoretical yield. 43.40952 grams of your adipic acid. So if you obtain 33.5 grams of adipic acid, what is the percent yield of the reaction? So you just divide 33.5 divided by the theoretical yield nato, which is 43.40952, meaning to say your percent yield or PY is equal to 77.17%. Again, anak ko ang 77.17. Divide this one, 33.5 grams of adipic acid or your actual yield divided by our theoretical yield or the computed value. So 43.40952. So this will be the result, 77.17%.